Hello students. In today's class we are going to discuss about the force of gravity. We know that the force of gravitation always exerted between the two bodies whenever they are separated by a certain distance. And the nature of that gravitational force is always attractive. And the expression is given by F equal to G m1 m2 by d square, where m1 and m2 are the masses of the two bodies, d is the separation between the two bodies, and g is the gravitational constant, which is also called as a universal gravitational constant, and the value is your 6.6 into 10 to the power minus 11 Newton meter square per kg square. Now force of gravity is a special kind of force of gravitation. So if your one body is very small with respect to other body, then that is considered as a force of gravity. For example, if you consider the mass of any object, for example, it can be a ball, it can be a book, or it can be an apple, it can be a leaf, any small object, and consider the another object as a earth. Now if you compare the two object, that is your small object, that is your apple or any other object, and the earth, so between these two there is a force of gravitation, but on that case we are not saying this as a force of gravitation, we will say this is a special kind of force of gravitation, which is called as a force of gravity. So what is the force of gravity? It is a special case of the force of gravitation when one among the two bodies has an infinitely large mass as compared to the other body. Now according to the Newton's law, we know that F is equal to ma. A is the acceleration. So whenever we are considering the mass of an object and the mass of the earth, on that case we are writing the F equal to mg. Here g is the acceleration due to gravity. So acceleration due to gravity is always act in vertically downward, and it is always acted towards the center of the earth, and the unit will be same, that is meter per second square. So what is the force of gravity? The force of gravity is equal to F equal to mg, and the force of gravitation is what? F equal to G m1 m2 by d square. If you see both the equation, you can observe in one case we have a capital G, that is called as a universal constant, and the another will be a small g, which is called as a acceleration due to gravity. We have the relation between this capital G and the small g. Let's find. According to the Newton's second law, if you have the force of gravity F equal to mg, here we have one small body m and another will be the large body capital M, that is your earth. Suppose this is the earth, and the distance between these will be d. So here F equal to mg, and also F is equal to, between these two body we have a G m1 m2 by d square. 1 and 2. Comparing this 1 and 2, mg is equal to, okay, here I am taking this one as a m and m, so we can write here one body as a m, another body as a capital M, this is d square. Now cancel the small m from both sides. So small g will be g m by d square. So this is the relation between small g and the capital G, that is the acceleration due to gravity and the gravitational constant. Now this one we can write in terms of like this also, gm by r square, where r is considered as the radius of the earth. Suppose this is your earth, its radius is your r, and the body is on the surface of the earth. So between this body small m and the capital M, the distance will be what? Distance will consider as a radius of the earth. So small g we can write as a gm by r square. Now we know that universal gravitational constant, that is your capital G, remains same in every place, everywhere. The value will not change in any place. The value remains same, that is 6.6 into 10 to the power minus 11 Newton meter square per kg square. But this small g does not remain same everywhere. It change place to place. Let's first see what will be the value of the acceleration due to gravity on the earth. To find the acceleration due to gravity on the earth, we have to consider the mass of the earth. Mass of the earth is your 6 into 10 to the power 24 kg, and the radius of the earth is your 6.4 into 10 to the power 6 meter. And yes, gravitational G, we know that this one will be 6.6 into 10 to the power minus 11 Newton meter square per kg square. Now if you put all this value in this formula, that is small g equal to gm by r square, put the values 6.6 into 10 to the power minus 11 into 6 into 10 to the power 24, 6.4 into 10 to the power 6 whole square. Now if you solve this one, we will get the value as a 9.81 meter per second square. So this one nearly equal to, always we consider as a 9.8 meter per second square. So acceleration due to gravity on the earth is your 9.8 meter per second square. Now let's find the acceleration due to gravity on moon. For moon, you have to take the mass of the moon, that is 7.4 into 10 to the power 22. Then radius will be 1.74 into 10 to the power 6 meter, and the gravitational constant will be 6.6 into 10 to the power minus 11 Newton meter square per kg square. So substitute in this formula gmm by r square. So here, after putting all the values, 10 to the minus 11, 7.4 into 10 to the power 22 by 1.74 into 10 to the power 6 whole square, we get here the value will be your 1.64 meter per second square. Now if you see both the value, this is 9.8, this is 1.6, which one is less? Yes, acceleration due to gravity on moon is very less than the acceleration due to gravity on earth. So if we compare these two, we can write acceleration due to gravity on the moon is always 1/6 of the acceleration due to gravity on earth. This is very important relation. Acceleration due to gravity on the moon is always 1/6 of the acceleration due to gravity on earth, because if you divide this one by 6, you will get the value 1.64. So this is the relation between the acceleration due to gravity on moon and on the earth. Now come to the next one, that is your mass and weight. What is mass? We all know that amount of matter contained in a body is called as mass, and the SI unit of mass is what? SI unit of mass is your kg. So what is mass? Mass is the amount of matter contained in a body, and it is measured in terms of kg. And if you have a body, then there will be a mass. So mass cannot be zero, and also mass does not have any direction. So mass is which quantity? It is a scalar quantity. Now what is the weight? Weight means it is the force of attraction. So weight is considered as a force, that is why its SI unit is Newton, because weight is a force. We can say the pull exerted on the body by the earth, or you can say the force exerted on the body by the earth is called weight. Weight is always acted vertically downward and towards the center of the earth. So since weight is considered as a force, so its SI unit is what? Newton. Force is measured in Newton. That is why the weight is also measured in Newton. Now it is always vertically downward, so it has a direction. So this is which quantity? It is a vector quantity, and it can be 0 because weight is given as a W equal to mg. So if g is 0, then weight is also 0. So what is the differences between the mass and the weight? Mass is the amount of matter contained in a body. Weight is a force exerted on the body by the earth. Second point, mass is measured in kg. Weight is measured in Newton. Third point, mass is a scalar quantity. Weight is your vector quantity. Fourth point, mass cannot be 0. Weight can be 0. These are the some differences between mass and weight. So similarly, weight on the moon is equal to 1/6 of the weight of the earth. These two relations are correlated. If the acceleration due to gravity is the 1/6 of the earth, then the weight on the moon 1/6 of the weight of the earth. For example, if the weight of the person on the earth is your 10 Newton, okay, weight of the person on the earth is your 10 Newton, then the weight on moon will be what? The same person will be 1/6 into 10 Newton. Okay. So the weight always decreases on the surface of the moon. So this is about your weight and mass. Now if you consider the earth has a always geographical equator and the geographic pole. Acceleration due to gravity at the equator is always considered as a minimum, and acceleration due to gravity at the pole is always maximum. So whenever the person moves from equator to pole, then the acceleration due to gravity is also increases. So be remember, acceleration due to gravity on the earth at the pole is maximum and at the equator is less. And if you want to find at the center of the earth, acceleration due to gravity is 0, because whenever you are coming to the center, you are saying about the center, on that time the radius is 0, means there is no distances between the two bodies. That is why at the center of the earth, if the person is at the center of the earth, on that time the person will feel weightlessness. That is your what? That is your acceleration due to gravity is 0. If the acceleration due to gravity is 0, the weight is also 0, because weight is the force which is given by W equal to mg. So in today's class we have learned about force of gravity, then acceleration due to gravity, the value of acceleration due to gravity on the earth, acceleration due to gravity on the moon. The relation between the acceleration due to gravity on the moon and the earth is your acceleration due to gravity on the moon is equal to 1/6 of the acceleration due to gravity on the earth. And similarly, the weight of the moon, weight on the moon is equal to 1/6 of the weight of the weight on the earth. So your work is, you have to read from page number 88 to page number 93, and then try to solve this question. Page number 98, do the question number 5 of the very short answer type question. Question number 5, very short answer type question, question number 5. And number 3, that is short answer type question. Question number 4, question number 5, then question number 9 and question number 10. Question number 4, 5, 9 and 10 you do in your physics copy. Thank you.